The metal core in a liquid-tight flexible metal conduit, U-lone, exceeding 6 feet in length must be grounded. National Electrical Code Article 250.118 addresses the grounding requirements for liquid-tight flexible metal conduit. The code states that a liquid-tight flexible metal conduit not exceeding 6 feet in length is permitted to be used without grounding. However, if the conduit's length surpasses 6 feet, it must be grounded in accordance with the NEC regulations. This grounding mandate serves as a critical safety measure, designed to mitigate the risks of electrical shock and fire hazards that can arise from faults within the conduit or the electrical equipment it connects to. Grounding offers a low-resistance pathway, allowing fault currents to flow safely back to the source. This prevents the buildup of hazardous voltages on the conduit and any equipment connected to it. Without proper grounding, a fault could energize the conduit, posing a significant shock risk to anyone who comes into contact with it. Furthermore, the increased resistance in the absence of a dedicated ground path could lead to excessive heat buildup, potentially igniting nearby flammable materials and causing a fire. To ensure compliance and safety, several acceptable grounding methods can be employed for liquid-tight flexible metal conduit. One method is to use a listed grounding connector that is properly sized for the conduit. The grounding connector must be securely attached to both the conduit and the grounding electrode conductor. The grounding electrode conductor must be connected to a suitable grounding electrode, such as a ground rod or a metallic water pipe. Another approach involves utilizing the metal frame of a building or structure as the grounding electrode, provided it meets the requirements outlined in the NEC. The connection between the conduit and the building frame must be made using a listed grounding connector. When selecting a grounding method, it is crucial to consult the NEC and other relevant standards to ensure adherence to all applicable requirements. Additionally, it is essential to verify that all grounding components are properly listed and rated for the intended application. The size of the grounding conductor is also a critical factor to consider. The NEC provides tables that specify the minimum size of the grounding conductor based on the size of the overcurrent protection device protecting the circuit. Using a grounding conductor that is too small can compromise its ability to safely carry fault current, potentially leading to equipment damage or personnel injury. Regular inspections and maintenance are essential to ensure the continued effectiveness of the grounding system. Connections should be periodically checked for tightness and corrosion. Any damaged or deteriorated grounding components should be promptly replaced. In summary, grounding liquid-tight flexible metal conduit exceeding 6 feet in length is a mandatory safety requirement according to the National Electrical Code. This practice protects against electrical shock and fire hazards by providing a low-resistance path for fault currents. Always adhere to the NEC and other applicable standards when installing and maintaining grounding systems. This includes using listed components, proper grounding conductor sizing, and regular inspections. Failing to ground liquid-tight flexible metal conduit properly can lead to serious safety consequences, including electrical shock, fire, and equipment damage. Article 250.4 of the National Electrical Code covers general requirements for grounding and bonding. It emphasizes the need for electrical systems to be grounded in a manner that limits voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines, and that stabilizes voltage to ground during normal operation. It also covers the effectiveness of the grounding path, requiring it to be permanent and continuous, and have the capacity to conduct safely any fault current likely to be imposed on it. Article 250.24 covers grounding service applied alternating current systems. It details the requirements for grounding the neutral conductor of an electrical service, which is typically connected to a grounding electrode such as a ground rod, ground plate, or metal underground water pipe. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, and is specified in NEC Table 250.66. Article 250.28 covers bonding jumpers. Bonding jumpers are used to connect metallic parts of an electrical system together to create a low-impedance path for fault current. This helps to ensure that all metallic parts are at the same electrical potential, reducing the risk of electric shock. Bonding jumpers are required to be installed around concentric or eccentric knockouts that are used to connect conduit to enclosures. Article 250.50 covers grounding electrode systems. It requires that all available grounding electrodes be bonded together to form a grounding electrode system. This helps to reduce the overall impedance of the grounding system and provides multiple paths for fault current to flow. Common grounding electrodes include metal underground water pipes, metal frames of buildings, concrete encased electrodes, and ground rings. Article 250.52 covers grounding electrodes. It provides specific requirements for the installation of various types of grounding electrodes. For example, it specifies the minimum length and diameter of ground rods and the minimum depth at which they must be buried. It also covers the requirements for concrete encased electrodes, which must be encased in at least 2 inches of concrete and be located within the bottom 5 feet of a concrete foundation or footing. Article 250.64 covers grounding electrode conductor installation. It provides requirements for the installation of the grounding electrode conductor, which connects the grounding electrode to the electrical system. The grounding electrode conductor must be securely fastened to the surface on which it is carried and must be protected from physical damage. It must also be continuous, and any splices must be made using irreversible compression connectors or exothermic welding. Article 250.92 covers bonding other enclosures. It requires that metallic enclosures containing service conductors be bonded together to create a low impedance path for fault current. This helps to ensure that all metallic parts are at the same electrical potential, reducing the risk of electric shock. The bonding connection must be made using a bonding jumper, which must be sized according to NEC Table 250.102. Article 300.3 covers conductors of different systems. It generally requires that conductors of different electrical systems, such as power, lighting, and control circuits, be installed in the same raceway, cable, or enclosure. However, there are some exceptions to this rule, such as when the conductors are separated by a barrier or are part of a listed equipment assembly. Article 300.11 covers securing and supporting wiring. It requires that wiring be securely fastened and supported to prevent it from sagging or becoming damaged. Wiring must be supported at intervals not exceeding those specified in the NEC. The supports must be designed to withstand the weight of the wiring and any other stresses that may be imposed on it. Article 300.14 covers length of free conductors at outlets, junctions, and switch points. It requires that a minimum length of free conductor be left at each outlet, junction, and switch point. This allows for easy connection and disconnection of devices and equipment. The minimum length of free conductor is typically 6 inches, measured from the point where the conductor emerges from the raceway or cable sheath. Article 314.16 covers number of conductors in outlet device and junction boxes and conduit bodies. It limits the number of conductors that can be installed in an outlet device or junction box or conduit body. This is to prevent overcrowding of the box, which can lead to overheating and other problems. The number of conductors allowed in a box depends on the size of the box and the size of the conductors. Article 314.17 covers entering boxes, conduit bodies, or fittings. It specifies the requirements for how conductors enter boxes, conduit bodies, and fittings. Conductors must be protected from abrasion and damage when they enter these enclosures. This can be achieved by using bushings, connectors, or other approved methods. Article 330 covers metal-clad cable type MC. It is a factory-assembled cable containing one or more insulated conductors enclosed in a metallic sheath of interlocking tape or a smooth or corrugated metallic tube. MC cable is permitted for services, feeders, and branch circuits in both exposed and concealed installations. Article 348 covers flexible metal conduit FMC. FMC is a raceway of circular cross-section made of helically wound-formed metal. FMC is permitted for use in dry locations and in concealed locations. It is not permitted for use in wet locations unless it is specifically listed for that purpose. Article 350 covers Liquidtight flexible metal conduit LFMC. LFMC is a raceway of circular cross-section having an outer liquidtight, non-metallic, sunlight-resistant jacket over an inflexible metal core with associated fittings. LFMC is permitted for use in both wet and dry locations. It is often used to connect equipment that is subject to vibration or movement. Article 356 covers Liquidtight flexible non-metallic conduit LFNC. LFNC is a raceway of circular cross-section having a smooth inner and outer surface with integral reinforcement within the conduit wall. LFNC is permitted for use in both wet and dry locations. It is often used in corrosive environments or where flexibility is required. Article 400 covers flexible cords and flexible cables. It provides requirements for the construction, installation, and use of flexible cords and flexible cables. Flexible cords and cables are typically used to connect portable appliances and equipment to a power source. Article 406.9 covers receptacles in damp or wet locations. It requires that receptacles installed in damp or wet locations be protected by a weatherproof enclosure. This helps to prevent water from entering the receptacle and causing a short circuit or electric shock. Weatherproof enclosures are typically made of plastic or metal and have a gasketed cover. Article 408 covers switchboards, switchgear, and panel boards. It provides requirements for the construction, installation, and use of switchboards, switchgear, and panel boards. Switchboards, switchgear, and panel boards are used to distribute electrical power to various circuits and equipment. They typically contain overcurrent protection devices, such as circuit breakers or fuses, to protect the circuits from overload and short circuit. Article 430 covers motors, motor circuits, and controllers. It provides requirements for the installation and protection of motors, motor circuits, and motor controllers. Motors are a common type of electrical load, and they require special consideration to ensure that they are properly protected from overload and short circuit. Article 430 covers overload protection. Overload protection is designed to protect a motor from damage caused by excessive current draw. Overload protection is typically provided by an overload relay, which is a device that senses the current flowing through the motor and trips the circuit breaker or contactor if the current exceeds a predetermined level. Article 430 covers short circuit and ground fault protection. Short circuit and ground fault protection is designed to protect a motor and its associated wiring from damage caused by a short circuit or ground fault. Short circuit and ground fault protection is typically provided by a circuit breaker or fuse. Article 500 covers hazardous locations. It provides requirements for electrical equipment and wiring installed in hazardous locations. Hazardous locations are areas where flammable gases, vapors, liquids, or combustible dusts are present or may be present in the air in sufficient quantities to cause an explosion or fire. Article 501 covers Class 1 locations. Class 1 locations are hazardous locations where flammable gases or vapors are present or may be present in the air in sufficient quantities to cause an explosion or fire. Article 502 covers Class 2 locations. Class 2 locations are hazardous locations where combustible dusts are present or may be present in the air in sufficient quantities to cause an explosion or fire. Article 503 covers Class 3 locations. Class 3 locations are hazardous locations where easily ignitable fibers or flames are present but not likely to be suspended in the air in sufficient quantities to cause an explosion or fire.